Hi, AP Stat students again. Welcome to Motivational Wednesday, March 25th. We are day 3 of Chapter 24. Chapter 24 is all about two sample means. Remember, we've gone through one sample proportion, then two sample proportions. We did one sample means last week, one sample mean, singular, sorry. And then two sample means. We're comparing to see if one mean is different or greater than or less than the other mean. Okay, Motivational Wednesday video is posted on Google Classroom. Please check it out. It's from Chino Hills High School. You might find it inspirational. In a nutshell, it is a group of students from the choir, the Chino Hills High School choir, who was supposed to have a show around this time, and it got canceled. So they did it online, and it's a beautiful song. So just a reminder, these are the questions that I want you to go through. Today we're going to go through number 21, or part A of 21, and then a little bit of 27. And your quiz is this Friday, okay? All right. So if you remember, we dealt with, in last chapter, we just had one sample. This time we have two samples. We're comparing the two. And again, the options for this is one going to be greater than, less than, or not equal to, okay? So we did this on Tuesday. So we're going to do this today. And then we'll talk about this tomorrow. All right. Oh, that reminds me. You may have received a message from AP Classroom or AP College Board saying that there are online lessons posted from you. And these are from other statistics teachers, so much better than me. Serious, not being sarcastic, being serious. However, the lessons for the next 3 days, Wednesday, Thursday, and Friday, they are from material that we won't cover this year. All right, so it's up to you if you want to watch it or not. This is the content of stuff that the College Board, the AP exam, removed for this year, okay? So right now, we're right here. We're talking about two different samples, two different means taken from two samples, okay? And we're going to be doing a hypothesis test. So sneak peek, it's going to be stat test option number 4, two sample t-test. All right. So the main idea, again, for inference, right, we're inferring something. We don't know what the entire pot of stew tastes like, but we are going to take a little sample and taste it to see if we can make an inference about the true mean or proportion. All right, so let's take a look at 570, number 21. Go ahead and pause the video and read that. It has to do also with number 19, so you may have to refer back to number 19, okay? So go ahead and pause the video and check that out. Okay, so once you've come back, we're gonna do part A only, okay? So go ahead and take a moment to read part A, what that's asking for. Okay. Part A is asking us to conduct a hypothesis test. All right, so sometimes they use the word, conduct hypothesis test. Other times you have to read the wording to figure out what it's asking you to do. All right, so let's write down our given information. We have two groups here. All right, so class, what do you think about that? You know, when you're watching television, you have shows with comedy, with drama, with violence, with sex, with drugs, with all these different types of contents, and your neutral, pure flicks type of stuff. Do you think that if a commercial showed during, say, a violent, gory show, that you would remember that commercial or that brand, whatever was being advertised, more than during a neutral, feel-good Hallmark type of show? Maybe, maybe not. That's what we're trying to see. So we are trying to, right now, if you take a look in your textbook, we are comparing the violent mean versus the neutral mean, okay? So we have two groups. I'm going to write down in our given information right here. We have two groups. We have the violent content, and then we have, I'll write that side by side, and then the neutral, okay? So we have the sample mean of violent, and we can use sub 1 and sub 2, but I'm going to use a V and an N. Okay, V for violent, N for neutral. The mean number of brands recalled was 3.02. The standard deviation of the violent was 1.61. And then the number of people or subjects or volunteers sampled was 101. For the neutral, we have mean is 4.65. Standard deviation of the neutral is 1.62. And then our sample size of the neutral is 103. So just 103 people sampled for the neutral and 101 people sampled for the violent. Okay? Just a quick look at the means. The mean, remember, this is the mean number of brands recalled during violent shows and then during neutral shows. Definitely the neutral shows is higher. I thought that brands would be higher during violent shows. I don't know, maybe you're like so captivated, so surprised from violent content that you don't really pay attention during the commercials or the brands. I'm not sure. Anyways, okay. So our step one, right? We have to define what mu of violent is, and then mu sub neutral. This is the true mean of brands recalled during violent shows. So this is the true mean of brands recalled during, oops, sorry, I ran out of space, during neutral shows. So we're going to write our null hypothesis and our alternative hypothesis. Okay. So the symbols you use here is very important. Remember, we are trying to make an inference. We're trying to infer something about the mean, the true means, based off of a sample. Okay, if we wanted to know the true mean, we'd have to sample every single person in the world. We're not going to do that. So remember, our null hypothesis is that nothing is different. So it's the same. The mu of violent equals the mu of neutral. Now go ahead and pause the video again and take a look at the wording of A, part A, asking, is this going to be greater than, less than, or not equal to? Okay. As you can see, it says, is there a significant difference? It's not saying is one greater or one less, just saying a difference, so it's not equal to. Okay. So you can write it like this. Or, remember, you could do mu sub v minus mu sub n equals 0, or mu sub v minus mu sub n does not equal 0. These are the same, okay? We're looking at the difference of means, difference of two means here. We're not going to do 3 means or 4 means or 5 means. It's only going to be comparing two. All right, so now let's go to the next section. Okay, so part 2, we have Nerton, and then we need to talk about T, A, T. I should have given myself a little bit more space. All right, so for the neutral content, this is on page 549. You can see, oh, by the way, let me just let you guys know that there is a good example on page 555 to 557, okay? So there's an example, see example of a hypothesis test, and they do this by hand as well, so you can check that out, the calculations, that is. All right, so the n, remember, we're not talking about certain this time. Whenever we talk about means, we're using the n for Nerton, which is a nearly normal condition. What are we saying is nearly normal? Are we saying the population is? And we're saying that the sample, okay? So we don't actually have the raw data of our 101 subjects. So we're just gonna assume okay, so we assume, and you gotta talk about both samples this time. We have 2 samples. We assume the sample the distribution of both samples are nearly normal. We don't know what they look like because we don't have the raw data, but we're just going to assume, okay? Now, independence. What are we assuming is independent here? There are three choices. Are we assuming that the shows are independent? Are we assuming that the brands are independent? Or are we assuming that the subjects or the volunteers, the people watching the shows are independent? Okay. If you guess the third one, you're correct. Okay. We assume each volunteer or each subject is independent. And you have to address both samples. And for both sample groups. Okay. Number or R. So randomly assigned. If you look at number 19, look back to the information there. There's a line that says the researchers randomly assigned volunteers to watch one of the three programs. So there was randomization that occurred. However, how do they choose these volunteers? Now, if it's a volunteer, it's probably not random, right? They weren't randomly chosen. They decided to volunteer themselves. So we could say, although each volunteer was randomly assigned to one of three shows, we will also assume that each volunteer was randomly selected. Okay. All right, so just think about a good experiment. You need randomization. Every single aspect has to be randomized, from the subjects you choose to how you place people in different groups or different blocks, right? It's very difficult to do. That's why working with humans sometimes is difficult. If you work with like animals or plates or pencils or like inanimate objects, is a lot easier to randomize. Now 10%. Each group has to be independent of their respective populations. So we assume that 101 subjects or volunteers, since we use the word volunteer up here, we should use volunteer. Volunteers is less than or equal to 10% of population. Okay, and also we assume that 103 volunteers, population, of viewers of violent shows. Class, do you think there are more than 1,010 people who watch violent shows? There are probably more than 1,010 people at Marshall who watch violent shows. We assume that 103 volunteers is less than or equal to 10% of population of viewers of neutral. What's a neutral show? I don't know. Can't think of one. The news? News can be violent sometimes. Speaking of which, I need to take a pause a moment, and I need to congratulate Ocean Cleary from Period 3. He won the lottery. Now, I would like more details. What kind of lottery? Are we talking like, a lottery amongst friends, or the world or the California lottery? Because that could be the difference of millions and millions of dollars. So, Ocean, please let us know what lottery you won and how much you won. And if you really want to share, please share. Please share. All right, so the TAT now. test, alpha, and then tails, okay? So test this time, we already talked about it. We're comparing two samples, so this is gonna be a two sample. Now, is it a sample proportion or sample mean? You guys know this is sample mean here. Two sample mean test, t-test, I'm sorry. Alpha, it wasn't given, so let's use 0.05 or 5%. And then for our tails here, since our alternative hypothesis was not equal to, remember what we're looking at, if we draw it out, it's going to be like this, not equal to, we're looking at both tails, because it could be less than or greater than. Okay? So it'd be two tails. All right, any questions? Good. If you have any questions, please email me. So part 3 is our calculation part. So we're going to do this by calculator, but if you want to do it by hand, you can take a look at page 555 to 557, and then calculator, page 558. If you write really fast, people will forgive your spelling errors. That's a secret. That's a life hack right there. I'm not proud of it, but I'm working on it. I'm working on my handwriting. Stat, test, and then we're going to option 4, to samp t-test. Okay, so go ahead and go there. I'm gonna go ahead, oops. I'm gonna go there in my calculator. Stat, test, sample t-test, and then let's choose stats because we have the statistics. I'm going to punch in those values, 3.02, 1.61, 101. So group 1, I'm going to make it my violent group, and then group 2 would be my neutral. 4.65, oops, 65. 1.62, and there were 103. So let me zoom in. This is what it should look like. Okay. So I'm going to hit enter. Oops. And you still need to do this. So mu1 is not equal to mu2, and then pooled. Remember from yesterday's video, I said just choose no for now. We'll talk more about this tomorrow. And I hit calculate. All right. So now we get a t-score. Why are we getting a t-score this time instead of a z-score? Because we're talking about a t-curve. It's going to be negative 7.208. So what that means is, since this is a not equal to with our curve, this right here, that's the number of standard deviations away, right? Normally, within 3 standard deviations is 99.7%. So this is way off there, way off there. But now also, it's going to be on this side as well, okay? This is going to be a positive 7.28 standard deviations above the mean. So this is going to be our mu right here. So with that, don't you think our p-value would be teeny weeny? It is. Our p-value is 1.11. And if you put this, that'd be wrong. What's wrong with that answer? Because several things, right? Well, number one, you did not copy the correct answer from your calculator, and a p-value is a probability of obtaining a test statistic of this or less or more extreme than this, and so a probability cannot be above 1. So this should be written as 10 to the negative 11. That's tiny, okay? Now let's also note our degrees of freedom here. They calculate it for you, 201.963. On page 549 is the calculation of how to do this. You don't have to know how to do it, okay? Just use your calculator. All right. So with that now, you can also scroll down and see a little bit more in your calculator. We need to now answer our conclusion. So since the p value of 1.11 times 10 to the negative 11 is way less than, the alpha of 0.05. Class, what do we do? Are we rejecting or are we failing to reject? Okay, let's just go back to what that means again. Are we rejecting this, our null hypothesis? That they're the same, that they're equal. We reject the null. We do have evidence of what? So refer back to your null and alternative, and also when you define your mu v and your mu sub n. It's the mean number of brands recalled during violent shows and then also during neutral shows. So we do have evidence of the true mean of brands recalled during violent shows to be not equal to that of neutral shows. Let me read this back. Since the p-value of 1.11 times 10 to the negative 11 is less than alpha of 0.05, we reject the null. We do have evidence of the mean of brands recalled during violent shows to be not equal to that of neutral shows. Right? Because remember, our alternative was mu v is not equal to mu sub n. Right. Bonus question, what type of error could we have made here? There's only one type of error, so remember, we go back and we look at what happened to our null. We rejected, right? So this would be a type. Everyone show me with your fingers what it is. Is it a 1 or is it a 2? It's a 1. Okay, that's the only type of error we could make here. Not saying we did, we could have, but if we did make an error, the only type of error is a type 1 error. All right. Number 27, I'm going to do it on a separate video because this video would be too long. Thanks, guys.